All right, we got some awesome bell work once again. A little bit algebra review. Looks like a little math typo here. This guy should be 2x squared plus 3x equals 9. Okay, we'll get to that one shortly. So find the value of y if 2y is equidistant to 5, 8, and 2, 1. Equidistant. So what's that going to look like? Let's see. I'm going to shrink this up so we have room to work. All right. So the distance from 2y to 5, 8 would look like this. So 2 minus 5 squared. You could have done 5 minus 2. It doesn't matter. And then y minus 8 squared. And that's equal to, we'd have 2 minus negative 2 squared plus y minus 1. So the distance from 2y to 5, 8 is equal to the distance from 2y to negative 2, 1. Okay, so I've got that all set up. Let's start working some numbers. Well, first off, I'm just going to get rid of these square roots by squaring both sides, right? I can't really fit what we have there. Let me see. Boom. Okay, I'll do that. That works. Now I can make that. Perfect. All right, so that cancels out my square roots. And in the same time, I'm going to do 2 minus 5 is negative 3 squared is 9 plus y minus 8 squared is equal to, and then I'm going to have 2 plus 2 is 4 squared is 16 plus y minus 1 squared. All right, so this is an interesting situation. I can't get the squared part on its own, just use square roots, because I'm going to have sum or difference on either side. So what I have to do is I actually have to FOIL it out. So I'm going to have 9 plus, and when I FOIL out y minus, y minus 8 squared, it is actually like y minus 8 times y minus 8. You can't just distribute the squared, remember. All right. If you do just distribute the squared in the test, then Mr. Allen will light your paper on fire. Okay. That's an empty threat. All right. So negative 8y and negative 8y give me negative 16y plus 64. And if you're a little confused on that, just think about it as y minus 8 times y minus 8. You might want to write it out like that if you're not comfortable doing it right now. But being able to do it in your head is a time saver. All right. And then here I'm going to have 16, and then we'll have plus y squared minus 2y plus 1. All right. So what's going to happen here is my y squareds are going to cancel out on each side, right? And I'm going to go ahead and combine some like terms. 64 and 9 gives me 73, so negative 16y plus 73 equals, then I'm going to have negative 2y plus 17. Awesome. All right. I'm going to get my y's on one side and then the number on the other. Okay, so I'm going to add 16 to keep it positive. That will give me 14y over here. And I'll subtract 17, which gives me, what, 56? If I divide that by 14, what do I get? I believe you get 4. Yeah? I think so. Y equals 4. So in this case, there's only one solution. A lot of the ones that we dealt with were 2 solutions. In this case, just 1. Okay, those squared terms cancel out, therefore eliminating the possibility for 2 different answers. Cuckoo. Next one. Factoring. My favorite. All right, first thing I need to do here is I need to set it equal to 0. So 2x squared plus 3x minus 9 is equal to 0. All right, now I need to set up that factor by grouping dealio. So what multiplies to, well, it's here. 2 and negative 9 is negative 18. And some of you guys may have seen this done differently, okay? It adds to 3. Well, that's going to be 6 and negative 3. That'll do the trick. Some of you at the middle school, if you learned this at the middle school, you might have learned it a slightly different way. There's lots of ways to factor with a leading coefficient. If you're getting the same answer as me and you're doing it a different way, that's totally fine. All right. So I split up that 3x into 6x minus 3x, which is 3x. And now I'm going to group. Okay. So if I group the first two and the last two, I'm going to pull out a GCF, which in this case is 2x. I'm left with x plus 3. The next one, I would pull out a negative 3, and I'm left with x plus 3. So I have 2x minus 3 and x plus 3. So my solutions would be, well, if I do 2x minus 3 is equal to 0, I'm going to get x equals 3 halves. And over here, x plus 3 is equal to 0. X is equal to negative 3. Cool, cool. There's a little algebra review. Let's get into the actual lesson. Okay, we're going into special right triangles here. 45, 45, 90 triangles and 30, 60, 90 triangles. Okie doke. Woo woo! Awesome. All right, looks like we got some issues with the PowerPoint here, but no worries. All right, so these are our two different triangles. We got our 30, 60, 90 and our 45, 45, 90 triangles. All right. Now, these types of triangles will come up all the time in Algebra 2 honors as well as pre-calc honors and regular pre-calc. Right, so knowing these triangles is very, very important. All right, they're used all the time with trigonometry and whatnot. So getting a good grasp on them is useful. So what this is saying here is that if it's a 45, 45, 90 triangle, we basically, if it gets bigger or smaller, it's just a similar triangle to the 45, 45, 90 triangle. For example, if I had, say, this side over here was 5, then this side has to be 5, and then this side has to be 5 root 2. Okay? So what we'll often do is we'll say this is x, which makes this guy x, and this is x times root 2. Okie doke. And another one that people will like to do sometimes if they like proportions, if you're very much a proportion type of fan, they do 1, 1, and root 2, and that's for your 45, 45, and your 90, the angle that it's across from, right? And then you can put in the sides that you know down here. So this one I would have put like a 5, since this was a 5. And then you can cross multiply and solve. We'll do both ways here with some examples. Same kind of idea over here with the 30, 60, 90, except for I would have 1 root 3 and 2. And this is for the 30, the 60, and the 90, the side that it's, the angle that it's across from. Okay? So say I had this guy here was 3. That would make this 3 root 3, and that would make this 6. Because it's double that. Okay? And you could have set that up in the proportion as well and done some cross multiplying. All right? Again, we'll show you both ways, and then you can kind of pick which one you like best. And one last thing that I forgot to add here, much like the other one, if we want to think about it as a formula, if this is x right here, then this guy's x times the square root of 3, and then this guy over here would be the 2x, right? So if you know one, you can multiply by root 3, or you can double it to get the other one. However, if you have one side, say I knew this side over here was 6, how would I get back to 3? Well, I would divide by 2, right? That's how you'd undo it. So if multiplying gets you one way, dividing gets you the other. Cool. Awesome. America. Let's practice. All right, so we're going to find some missing sides. Looks like we're dealing with 45, 45, 90 triangles for both of these. So let's do it. This first one here, we've got 8 for one of the sides. Now, if I remember, this is my 1, 1, and this is my root 2 over here across on the right angle. So and I can think of that as like 1x, and x root 2 if you'd like. So if this side's 8, then this side has to be 8 right here. And then if this is 8, then this is going to be 8 root 2. Boom. There's our two solutions. Awesome. You also could have set this up in a proportion. So the side with the 1 was 8. And then we didn't know the other one, but it's going to be 8. We know that. So let's just do the root 2. And what's across the root 2? That's my y. When I cross multiply, I'm going to have 1y is equal to 8 times root 2. And that's the same answer that we had right over here. Isn't that lovely? All right. So let's take a look at this one. Here it's a slightly different situation. Well, to go from this side here to this, we'd multiply by root 2. So to go from here to here, we need to divide by root 2. So I'm going to have 9 divided by root 2. But I got to rationalize that, so root 2 over root 2, which equals 9 root 2 over 2. That would be for my x and y. Okay? I'm just going to add that in there. If I wanted to set up the proportion, I could do that. I'd have 1 over x is equal to root 2 over 9. And again, the x and the y are going to be the same. So having the super proportion with 3 isn't really necessary because what's across from the 45 is going to be the same as the other one, right? Because they're both across from 45s. So when I multiply these, I get 9 is equal to x root 2. And then to solve that, I would be dividing by root 2. And you can see that we are going to get the same result. Because these cancel, so I get x equals, if I rationalize, 9 root 2 over 2. Boom. All Gucci. Wonderful. All right, let's practice with some 30, 60, 90s. So we got two different problems here. One where C is 12 and one where B is 9. So we're going to treat those as two separate problems. We've got to find the missing sides. So if C were to equal 12, well, I can set up a proportion, my super proportion, if you will, where I've got 1, root 3, and 2. Well, across from the 2 is going to be with the 2 is going to be the 12 because that's my largest side. That's across my right angle. And then across from the 30 is my A, and across from the 60 is my B. And I can just go ahead and cross multiply and solve if I'd like. So I can treat them as two separate proportions from here. So I can cross multiply these two, and then I can take this one and cross multiply with this. Okay, and you'll get the same answers that I do in my preferred method. If C is 12, then I know that A is 6 because it's just half of that, and then I know that B is 6 root 3 because I know it's root 3 times whatever the A is, right? Whatever's across from the 30 multiplied by root 3. So if you can work on getting back to the side that is across from the 30, then it's really easy to get to the other two sides, okay? So let's do this one now. I'll change it to red for this one. So if B were 9, then what? Well, again, we could set up our proportion as 1 over A equals root 3 over, in this case, 9, and then 2 over C. So I'm looking for A and C. And I can cross multiply and solve, and you will get the same answer of what I'm about to get. I know to go from A to B, and I have to multiply by root 3. So in order to go the other way, I need to divide by root 3. So this right here is going to be 9 divided by root 3. And to rationalize that, I do root 3 over root 3. So I'm going to get 9 root 3 over 3, which is 3 root 3. So that's A equals that in this case, 3 root 3. Okay, after simplification. So it got a little messy. But this makes it real easy to find C. What do I know? To go from A to C, I just double it, so it's 6 root 3. Again, I personally like this way best, but for those of you that feel much more comfortable with the proportion, you're more than welcome to set it up that way. You will get the same answers if you do it right. Ooh, a fun little problem here. Find the perimeter of the trapezoid. By the way, I'm making this video as I eat my lunch here today because there's nothing that I love more than eating lunch and making math videos, right? Got a chicken tortilla soup that I made last night, and now the leftovers of that chicken tortilla soup, the leftovers, that chicken and other good, we made into chicken enchiladas tonight. Very exciting stuff. All right, I decided to also add in a little bit of a red pepper in there this time. It was delightful. So let us get to the math. All right. Well, if it's a trapezoid, why don't I just drop an altitude down? Boom. Make that perpendicular. Turn that into a right triangle, which makes this a right angle. And if we got 60 and we got 90, we know that this up here is going to be 30. Okay. And if I drop this down, I know this portion is going to be 12 because I just created a rectangle and my opposite sides of a rectangle are congruent, which makes this 3. And if that is 3 across from the 30, double that is 6, which is that slanted side, one of the legs of the trapezoid. and my height is 3 root 3. Now, that is not part of the perimeter, but opposite sides of a rectangle are congruent, so this is 3 root 3. So what do I have here? To find the perimeter, I've got to add them all up. So I've got 15 for my long side down here, right? 15 for this, or 3 plus 12, which is 15. So 15 plus 6 plus 12 plus 3 root 3. So 15 plus 6 is 21, plus 12 is 33, plus 3 root 3, and we'll just leave it separate like that. Generally speaking, we'll leave them in terms of like simplified radicals and all that. Decimals will sometimes be accepted. Just make sure you read the directions. All right, find the perimeter of a square with a diagonal of 12 centimeters. Why don't I draw a lovely little square first? We've got a diagonal of 12. Well, what do I know about my angles of a square? They are right angles. And I also know that the diagonal bisects them, which makes this into a 45-degree angle, and then the same would happen over here. So I've got a 45, 45, oops, not a 44, 45, 45, 90 sitch going on here, right? Well, to go from my hypotenuse back to the leg, I divide by root 2, so 12 over root 2. All right, actually, why don't I do that over here? 12 over root 2. So then I'm going to rationalize it. I'm going to get 12 root 2 over 2, which is 6 root 2. So this is 6 root 2. It's a square, so all of them are going to be 6 root 2. So 4 times 6 root 2 is equal to 24 root 2. Boom. Awesome. There's my perimeter of this square. Again, you could set this up with the proportions. You would have 1 over x is equal to root 2 over 12. Cross multiply, solve for x. You're going to get 6 root 2 for your side length, and then go from there. All right? So proportions are cool. I like doing it the way that I did it first, but it's up to you. All right, so this another lovely problem here. We're going to solve for x, y, and z. 3 problems in one. How wonderful is that? And it looks almost like the altitude on hypotenuse problems, but we can actually solve this with 30, 60, 90 triangles. Let's do that, since that's what we're practicing. All right, so I've got this value, 12 root 3. Now, I'm going to do it the way where I solve for each individual side rather than setting up the proportion. I know that if I can get y first, that's across my 30, that'll make things a bit easier to solve for x. Well, my hypotenuse, the long side there across from the 90, is just double whatever y is. So if I cut that in half, y is equal to 6 root 3. All right? Let's divide by 2. So to get from here to here, divide by 2. Cool. And then to get to here, I need to multiply by root 3. Yeah. So if I do 6 root 3 times root 3, I'm going to get 6 times 3, which is 18. So although like you usually think of the ones that are across from the 60 having a root 3 in them, it doesn't mean that it has to have a root 3 in the actual length. It just means that it's root 3 times bigger than the one that's across from the 30. Okay? Often we see the root 3, but it's not required. All right? Now, to get z, I have the one that's across from the 60. This right here is the 30. Well, to go from here to here, I would need to divide by root 3 to go from across the 60 to the 30. So when I do that, z is equal to 6 root 3 divided by root 3. Those cancel, and I'm left with 6. Boom, there we go. I've got all 3 of my solutions. 18, 6 root 3, and 6. Excellent. Lovely. All right, so we want to find the length of the hypotenuse of an isosceles right triangle if the lengths of the other two sides are 3 inches. So an isosceles right triangle, well, that would mean that this guy is right, and we want to find the hypotenuse. We'll call that x. So this guy is 3 and 3. Now, how did I know that that one's the right angle? Well, it can't be the bottom two because you can only have 180 degrees in a triangle, and that would already take it up. So you got to have enough room. So that one needs to be the right angle, which would leave these two being the same, a 45, 45, 90 triangle. And how do I get from the leg to the hypotenuse? 3 root 2. Boom. No big deal. Yeah. Woo-hoo. So it's about identifying these things as well. Okay? You need to notice this stuff that's going on. All right, and the last one, find the perimeter of the isosceles trapezoid. So with these trapezoid problems, I always like to drop down altitudes, which make right angles, right? And the wonderful thing about that with an isosceles one is that, okay, well, this is going to be 10 right here, right? Which leaves 14 left over, so these are 7 and 7. It's equal, right? Because it's isosceles, so it's going to be symmetrical, right? Excellent. Okay, well, if this is 45 on the left, then this has to be 45 on the right. So we're dealing with two 45, 45, 90 triangles. And I want to find the perimeter, so I need to find out what this is right here as well as this. And it's going to be the same, right, because it's an isosceles trapezoid. Well, how do I get from my side that has the 45 to the hypotenuse? Just multiply by root 2. There we go. Boom. There's my side length. And 7 root 2. So my perimeter is going to be all my sides added up. So 24 plus 10 is 34, plus 7 root 2 and 7 root 2 is 14 root 2. Bada boom, bada bing. We done. Excellent. Wonderful. Great, grand, awesome. Cool. So if you do end up taking the ACT along with that SAT that you're required to take, you will see a little bit of geometry in there, and they love these special right triangles and all that stuff on the ACT. Yeah. America.